We'll continue from the where we are left, the last part. Okay, it is strain. Okay, what is strain? In the simple words, due to the application of load, okay, on a body, there are some deformations. Okay, there is an increase in length, there is a decrease in length, there is a distortion of an angle, or there is an when tangential force is applied, there is a shear stress. Okay, whatever might be this deformation, the increase in the deformation or the decrease in deformation, we are not talking about the total length. Okay, we are talking about the only increase or only decrease that is happening on the body, that is called as strain. Okay, as per the definition, if you see, okay, the deformation produced by the application of the load per unit area on the member. Okay, okay, it is denoted by the alphabet small e. Okay, it is a ratio between the change in dimension to the original dimension. Okay, deformation produced by the application of the load per unit area of the member. Okay, it is we denoted by e, and one important thing is it has no units. Why? Because it is a ratio between the two uh, di- dimensions of same units. So if it is length, then meter by meter cancel off, so you don't have any units, it is unitless. It is unitless. So as we saw the various types of stresses, same way we have same types of strains. For uh, how we have tensile stress, we have tensile strain. If you can see here the object, okay, the original length of the, if you can see here, the original length is L, right? Due to the application load P, okay, there is some increase or some deformation happening. It is delta L. Okay, this is L, this is small deformation happening, so we say it is a delta L. So the change in length, okay, to the original length, okay, the original length, that is called as tensile strain. Okay, so that is called as tensile strain, because there is an increase in deformation. Okay, there is an increase in deformation, so it is called as tensile. Okay, and it is pulling the object downwards, so it is tensile. Next is compressive. Okay, next is compressive. You can see here, the length L, original length L, and the decrease in, sorry, this is what you have the length L, and this is the decrease in the length. Okay, so the decrease in length is how much? This much. It is delta L. So the decrease in length, okay, delta L, upon original length is called compressive, because you are pushing here and are decreasing, there is a decrease in deformation, so it is called compressive strain. Okay, next is shear strain. So what is shear strain here? As you can see, a tangential load is applied to the object, okay, which is fixed at a bottom. Okay, so what is happening is the upper surface or the object is trying to distort or have a deformation, angular deformation. Okay, there is a deformation which is angular. Okay, so the difference in the theta to the original theta, that is called as shear strain. Okay, this is what is the length, right? We'll calculate the L from this theta, okay, and we'll divide it by the original length, because there is a, we don't get directly the difference in length here or deformation length, so we have to do it by that theta or deformate angle or distort angle. We have to find out the L and DL, and then we have to calculate the strain. Okay, next is elastic moduli. Okay, moduli is a plural word, modulus is a singular word. There are number of modulus, so we are calling it as moduli. Okay, the first one is Young's modulus or the elasticity modulus. Now what is this Young's modulus or elasticity modulus? Okay, the ratio of tensile stress or compressive stress to the corresponding strain is called as Young's modulus. Compressive stress upon compressive strain, the ratio between the compressive stress upon the compressive strain is called Young's modulus or elasticity modulus. The stress is denoted as sigma upon E, small letter e. This is what is Young's modulus is. Okay. Next is rigidity modulus or shear modulus. So the ratio of shear stress to the corresponding shear strain within the elastic limit is called as modulus of rigidity. Okay, there is another one, okay, which is called as bulk modulus. Okay, it is volumetric strain by volumetric stress by volumetric strain. Change in the the strain in the stress in the volume upon the original volume, which will give us this strain in volume. Okay, so that is called as bulk modulus. Okay, next is factor of safety. Okay, what is factor of safety? The ratio of ultimate tensile stress or compressive stress to the working stress. Now first thing we have to understand what is this tensile stress and what is this working stress. So we'll try to understand what is. Okay, we'll try to understand the what is tensile, ultimate stress and working stress. If a body okay is loaded with the maximum load is applied and it is on the verge of failure. Means what? The We have applied the full load or the maximum load on an object. Okay, that if we increase the load by the one magnitude, okay, or one magnitude, then it will fail. Okay, then if we increase the magnitude of the load on that object, okay, then it will fail. At that load on which it is standing, that is called as ultimate load. It is called as ultimate load. Ultimate load, right? Understood what is ultimate load? The maximum load applied or object before the failure. Okay, just before the failure is called ultimate loading or load. Now, what is working load? Load. Okay, what is working load? So working load is nothing but the maximum load. This is also a maximum load applied on the object or a body. Okay, applied on the body. Okay, such a way that such a way that the um, working load which is going to be uh, taken by the object or life along its life. Okay, the maximum load which will be applied throughout its life. Okay, whatever the loads are going to be applied over that body throughout its life, that load is called as working load. Okay, understand this thing, it is very important. Okay, whatever loads we are going, if this is your body, okay, and it has a span of 30 years. Okay, the lifespan of this body is 30 years, and we are going to apply all the forces, all the maximum forces. Okay, and that maximum force is called as working, because during the working condition of that body or the structure, during the working condition of that structure, these are the working loads that are going to be acting over it for the span of 30 years, right? These loads are called as working load. Okay, and the stress developed is called as working stress. Okay, it is called as working stress on an object when you apply the maximum load. Okay, maximum working load that it is going to serve along its span. Okay, that type of loading is called as working load. So you might ask whether it is greater than ultimate load or it is lesser than ultimate load. Obviously it is always lesser than the ultimate load, because we don't want our object to fail. If a building in which we are living, okay, we apply the ultimate load, then it is on the verge of failure. It might, if certain increase in the load is there, the building will fail. So we will try to build the house such a way that we are in the working conditions or working load. Means this will be lesser than the ultimate load in which we are going to apply the loads. Okay, okay. So what we do is we have some factor of safety for it. So by how much percent or how much percent we have to maintain the difference between this working load and the ultimate load. We calculate this by dividing the ultimate load by the working load. Whatever the load is coming on that structure, and what is its maximum capacity of that structure. When we divide it, we'll get the ratio of it. So that ratio is called as factor of safety. Okay, if I try to explain you graphically, consider that this is the stress strain graph of a object or a structure. Okay, this is a point of ultimate load, and okay, and okay, and the load acting over the structure or that structure is somewhere here. Okay, means what? The ultimate load of the that structure is this point. Okay, this point, right? And whatever load we are applying is, it is still here. Okay, this difference, the gap between the between the ultimate load and the working load. Why it is called working load? Because we are going to work on these loads. This load is going to be applied throughout its lifespan, so it is called working load. Okay, the gap between this is called as safety factor. So we have to find out this safety factor. To find out this safety factor, we find out the difference between the ultimate upon the working load. We'll get this factor of safety, and usually for the building it is ranges from 1.5 to 3. Okay, for structures nowadays it is 1.5, previously it was 3. Okay, you can see the formula once again here. The factor of safety is equal to the ultimate stress to the permissible stress. Permissible stress is nothing but the working stress. Okay, next is longitudinal strain. This is something different. Okay, when a body is been subjected to the axial tensile load, okay, there is an increase in the length of the body. That increases along the longitudinal direction of that body. So it is called as longitudinal strain. Okay, the increase in the body length is along the longitudinal direction, right? So the strain is called as longitudinal strain. Okay, then comes next lateral strain. Next calls is lateral strain. Strain at a right angle directions to the applied load. Okay, if this is an object and this is an application, and the strain is along this direction, it is increased along its transverse direction. Okay, then that type of strain, okay, that type of increase or decrease in the deformation is called as lateral strain, because the deformation is occurring along the transverse direction. Okay, so it is called as lateral strain. Next is Poisson's ratio. The difference or the ratio, okay, the ratio between the lateral force and the longitudinal force or the longitudinal strain, sorry, it is the ratio between the lateral strain and the longitudinal strain under the given material with the elastic limit. Okay, what is elastic limit or elasticity? We studied the property, right? Whenever the body is loaded with an object, it deforms, and when the load is removed, the body comes back to its original position. To what extent if we load, okay, this elasticity will remain. The verge at which if we increase the load after that, if we increase the load after that point, okay, the deformation will become permanent and the body will become plastic body. Okay, so that limit till where the elastic um, property acts, okay, that point is called as elastic limit point. Understanding what I'm saying? That whenever a body which is applied load, okay, it deforms, and whenever the load is removed, it is goes to the original shape and size. Till what extent? Till what extent, if we load, this elastic property will remain. Okay, if we increase the load beyond this limit, then the deformation will become permanent. So that limit is called as the elastic limit. Beyond that, the body will not act as a elastic limit, elastic body. It will act as a plastic body. That is called as elastic limit. Okay. So this Poisson's ratio is denoted as U mu or m. Okay, and this Poisson's ratio is constant for all the materials because every material has a lateral strain and longitudinal strain constant. Okay, so the Poisson's ratio also remains constant. Next is type of loading. Okay, whenever you apply a body a load, okay, in the normal conditions, that is called as gradual loading. Okay, it is called as gradual loading. On a body, if you apply a sudden load, okay, if you apply a sudden load, okay, that type of loading is called sudden application of loading. Okay, then what is the third? What is impact load? On a body, we apply the force from some height h. On a body, okay, we apply the load p from some height h. That type of loading is called impact loading. Okay, the remaining part, that is your temperature stresses and the problems on this, okay, stress and strain will be covering the next part. Okay.